Let me share my screen, then we can start.
Sir, good morning.
Good morning, Pranadas.
सर लैब कर रहा था तो
Mm-hmm.
लास्ट में थोड़ा सा लैब में थोड़ा इशू हो रहा था, आप थोड़ा सा हेल्प कर दीजिएगा।
Yes, you want to share your lab?
यस सर, लैब।
What issue are you facing right now in the lab?
सर पालो अल्टो का वो ओपन नहीं हो रहा है सर।
Okay, let me. Can you share your screen? Let me make you the co-host. Yeah, please share your screen.
स्क्रीन इज विजिबल सर।
Yes, it's visible, visible. Okay, just maximize it. Just maximize this. Hmm. Allow, allow. Okay. Can you just go and press enter on this CLI? Log in with CLI username and password.
सर यहाँ पे नहीं ले रहा है।
What username and password you have put it there?
सर एडमिन और जो मेरा एडमिन एडमिन भी दे दिया हूँ, और एडमिन और जो न्यू
Can,
पासवर्ड है वो भी दिया
can
हूँ,
you
वो
just
भी
try
नहीं ले रहा।
admin, admin? Can you try admin, admin?
हाँ, एडमिन एडमिन
Okay, go in
नहीं।
the lab topology. You must, put the wrong password na somewhere. Go in the lab topology. Click on the
हाँ
firewall.
हाँ
Pencil icon. Up. Pencil icon. Yeah.
हाँ हाँ।
It's a 10.0, right? This firewall. So this is not going to take admin, admin. Let me put the password in the chat. DAUD@123. Can you try this admin? I put in the chat.
I hope I have that.
No, just do not share a credential. Why are you sharing credential on the screen?
Hmm.
Please be careful, na. Just log in. Just log in. I question in chat in the team chat.
UD 123. User ID admin.
Yes, DAUD decaps.
Hmm.
That's working. So you're not trying the right credentials, right? That is the problem. So try to check like which firewall you are accessing. 9.0, it's admin. Now go in the GUI again.
One second, sir. Source system info.
Hmm.
11.0.0.89.
Hmm. Bring it. Hmm. Okay, just ping, just go in the CMD, ping this IP address.
हम्म,
Now its page is open.
हम्म,
You can log in. D capital.
AD admin DAUD@123.
What's working?
हाँ सर, और एक चीज पूछना था। कभी कभार हो रहा है सर इसमें, कोई पीसी आपका मतलब नहीं चल रहा है, तो तब इशू हो रहा है, तब क्या करूँ?
Just right click and restart. Right click and wipe. Right click and wipe. Right click on the PC and wipe. Right click and wipe.
अच्छा, वाइप करूंगा चला जाएगा। अच्छा, और
Right.
एक चीज है सर, यहाँ पे मेरा हर टाइम 4-5 लैब एक्टिव दिखा रहा है। कहाँ से वो मैं देख रहा था कल रात को भूल गया।
So try to shut down your lab now. Whenever you're doing the lab, you try to shut down your labs.
तो
It
कहाँ
will
से करूँ सर, वो सर एक बार बोलेंगे?
just go in setup nodes. Up,
अच्छा,
up.
सेटअप
Yes.
नोट्स।
Stop all nodes.
अच्छा, स्टॉप ऑल नोट्स, ओके सर।
Hmm. Okay. All right. Just stop your sharing. Let me share my screen. We can continue
ओके
from
सर,
there.
थैंक यू सर, थैंक यू सर।
Okay. All right, guys. So we discussed about the content ID, and almost we did all discussion in the content ID. In this content ID, we discussed the antivirus, anti-spyware, vulnerability protections. Also discuss about the URL filtering. We discuss about that file blocking. We discuss about the wildfire data filtering dot protection. So everything we discuss in our content ID chapter. Now we have to discuss about the SSL decryption. So we have to understand what is SSL decryptions and why SSL decryption is needed in the Palo Alto Firewall. What is the concept of the SSL decryptions? How SSL decryption is going to work? Step by step process we are going to understand, and then we'll try to do the labs and all. Okay, so we are targeting this module, that is the SSL decryptions. Okay, so we have to understand what is the certificate management, what is the outbound SSL decryption, what is the inbound SSL decryptions. So let me explain, right? As we discussed in our sessions, generally whenever going to do any kind of the communication over the internet, especially for the web traffic, there is a two kind of the communication for the web traffic. Okay, so one is going to be your HTTP based communication, that is going to be happen on the port 80. Another is going to be HTTPS based traffic, that is going to happen on the 443. So what is the port 80 and what is the port 443? So port 80 is basically it's a non-secure traffic, and generally all traffic is going in the plain text. So plain text is like firewall is going to be see what is sending, what you're sending in your packet, what you're receiving in a packet. Similarly, if you go for talk about the HTTPS, it's completely going to be your secure communication. And in this secure communication, your entire packet is going to be encrypted. So it is going to be encrypted. So your end-to-end encryption is going to happen. So let's suppose you're sending any packet on the internet. Let's suppose this is your client machine. This client machine connected with the somehow with the firewall, right? Firewall is connected to the internet. Very basic topology. And you trying to communicate on the internet and trying to upload some file on the Google Drive. You want to download some file from the internet. And if that communication is going to be in HTTPS, then what is going to be happen? In that situation, firewall will never going to understand what data you're sending and what data you're receiving. So in case if your file having any kind of the virus, right, any kind of the malware, any kind of the vulnerability attack, right, any kind of the bad URL, any kind of the other bad things, content, file, could be anything. So it is never going to understand, because firewall will never going to by default understand what traffic you're sending in the in encrypted format, what traffic you're receiving in the in encrypted format. Because if you already done the encryptions, that means your traffic is fully encrypted and there is a no visibility at all in the firewall. So that challenge is going to be happen in your real production environment. So in real production environment, multiple users are accessing the multiple applications, multiple files, a lot of things they are doing that. And they keep sending the traffic, keep receiving the traffic from the LAN to internet, internet to LAN. And firewall is going to be always unaware what traffic you're sending and what traffic you're receiving. So it is going to be completely unaware. So that's not good for your business. If user might be leak your data, there is some sensitive data in this particular PC, and you say my data should not be leaked on the internet, but you have the Google Drive access. And Google Drive is basically, if you just go and open the Google Drive, it is going to be completely HTTPS based website. Let me show you. If you go on the Google and open the Google Drive, let me show you where is a drive. There is no drive. Yeah, this is drive. So you see, this website, you see, this is the HTTPS website. So 99% the communication you're doing in the internet, even you're opening the Google as well, they all are going to be HTTPS. So if they are the HTTPS, then how firewall is going to come to know what data you're sending, what data you're receiving, is there any malware, is there any virus, is there any kind of other communications which is not comply with the company policy, that is going to be received or not. So in that case, decryption come mandatory. So technically, decryption is not, SSL decryption is not basically. So if you're going to listen the word SSL decryption, if you're going to listen about SSL inspection, okay, technically both are same. Okay, don't be confused. So if you're somebody saying SSL decryption, SSL inspection, that is same. If you're going to listen TLS decryptions, and somebody is going to talk about the TLS inspection, it is also same. And in very, in nutshell, SSL and TLS are same. Why SSL? Why TLS? Probably you're going to find TLS decryption, or you're going to find like this one, SSL slash TLS inspections or decryption. So don't be confused. So earlier SSL is referred as a SSL is basically referred as a secure socket layer. So this is the basically secure socket layer. It's one of the protocol that was the quite old protocol, and this protocol now has been replaced. This protocol has been fully replaced with the new protocol that is known as the TLS. That is technically known as the TLS stand for the transport layer security. So nowadays, any communication you are doing on the internet, those all are the based on the TLS, and they have a different version. They come with a TLS version 1.0. They have the TLS. Sorry, yeah, TLS. This is wrong. Okay, just ignore. This is not TESL. This is TLS. You're going to find version 2.0. You're going to find TLS 3.0. So nowadays you're going to find different version, and different version have the different security. So latest version you're going to find the TLS 3.0. This has been also deprecated from market. SSL has been also deprecated from market. No one is using the SSL. SSL has been completely replaced with the TLS. So this is not a transport layer security. That is a layer 4 security. Means one of the strongest security for your any kind of the layer 4 communications end to end. And this security, what is going to happen? Your end to end SSL packets or TLS packet, or might be you're doing anything, it's going to be completely encrypted. So in in Palo Alto, we know as a SSL decryptions or TLS decryption, but if you're going for the FortiGate, you're going to known as the SSL inspections. checkpoint also SL inspections. And if you go for the Zscaler, also you're going to get as a SL inspections. So don't be confused. The meaning are going to be same. Now, how this architecture is going to work? If I talk about the TLS or SL inspection, the architecture is going to be look like in this way. Let me bring one of the ebooks as well for your reference. So I'm going to bring one of the Palo Alto ebook. So you guys will get more insights. Give me 1 second.
Is there any difference in TLS and SSL?
The same.
Architecture?
The only TLS was SL was latest. Sorry, TLS was old. SSL. Oh, my bad. SSL was basically old. TLS is basically latest. That's the only difference we have. No more than that. I'm going to show you even the packet level. If you open now, let me open the WireSAC. There is no such difference you're going to find. Technically, both are same. If you go and find here, let me capture some packet here. There is some packet and just search here SSL. See, if you're searching SSL, what you're getting that? TLS packet you're getting 1.0, 1.2. Sorry, I mentioned that version 1.0, 2.0, 3.0. No, it's not like that. 1.1, 1.2, and 1.3. That is the version, correct version. So you can see when I'm searching SSL, it's getting a TLS packets. And if you click on this particular sign, you can see SSL is deprecated in favor of TLS. So that's completely mentioned that SSL is no more in the market. That has been completely replaced by the TLS. So earlier it was SSL, but now it has been become the TLS. Clear? DK? Who asked this question?
Yes, yes.
Yaperness. So there is no such difference. And version is not actually my bad. The version I was talking about that is not correct version. Let me replace. So this version is going to be like this. So let me, yeah, this version is going to be TLS version.
1.2.
Yeah. This old version is TLS 1.1, right? TLS, you're going to get 1.2, and TLS, you're going to get 1.3. This is the latest. Again,
TLS or SSL?
no, this has been SSL is not more available, na? SL is
Okay.
more available. You can see only you're getting a TLS version here. If you go there, na, TLS.
Okay.
Yeah. So you're getting only, see, 1.3 version also you're getting here, but 1.1 is now available in the market. 1.1 has been totally gone from the market. Now, if I talk about the architecture, right? SL decryption. So, what is the idea for the SL decryption? So, SL decryption in Palo Alto network, that having only major requirement that decrypt and inspect the traffic and provide the visibility into threads and the control protocols. Like they are going to be validated certificates, they are going to handle failure handling, and decryption can enforce the policy on encrypted traffic. Means if there is already encrypted traffic, you cannot do any kind of the enforcement of the any security policies, whether they have the virus, malware, file, vulnerability, spying signature or not. But once you decrypt, you have the complete visibility of the packet. So decryption can enforce the policy on the encrypted traffic so that firewall handle the encrypted traffic according to your configured security settings. Decrypt traffic to prevent the malicious encrypted content from entering your network and sensitive data or content from leaving your network, considered as a encrypted traffic. So that is a key advantage. But when we're going to do the decryptions, you go and see here and you find the key architecture for decryptions. See, this is the client and this is the server. So in case of the decryptions, what is going to happen? It's not going to be very straightforward communication from the client to server. Let's suppose this is the one of the PC want to talk with a Facebook server, right? Or might be any other server, any G Drive, Google Drive. So you cannot make direct communication from client to PC. No, you cannot make direct communication. Generally, in my PC, if I'm going to access the any Facebook doc communications, my PC is directly going to talk to my client. Right, my client is going to PC is directly going to communicate with my servers. But in the SL decryptions, there is a proxy architecture. In this proxy architecture, what is going to happen? Your connection is going to intercept always by the firewall. Okay, so when you initiate the connections, this is the first connection. It is going to intercept by the firewall, and on behalf of you, firewall is going to initiate the new connection to your server. So this is your first connection, this is your second connection. Similarly, if your reply is going to happen, your firewall is going to again intercept your reply, and on behalf of you, it is going to initiate the connection with the client. This is the four architecture. It's a very high level, I'm talking about that, but in between, they will do a lot of checks as well. It's not like immediately when you go into reach, it will immediately going to connect with the server. No. What is going to happen when client going to initiate this connections from the firewall and the client? It's going to be your HTTPS connections. Means client to the firewall HTTPS is secure connections. When firewall is going to communicate with the server, again it's the HTTPS connections. So this is the second HTTP connections. When server is going to reply to the firewall, again it's the HTTPS connections. Right? Again, the firewall is going to reply to your client. Again, it's going to be HTTPS connections. So all connections are going to be your HTTPS connections. But the time your packet is going to stay in the side of the firewall, that is going to be your plain text packet. Means it's not going to be HTTPS connection. It's going to be fully plain text visible packet inside of the Palo Alto firewall. Right? And how it is going to happen, that we have to understand all the process. So you can see the very first packet, when client initiate the SSL session with the server, firewall intercept your SSL connection. Guys, can give me 1 second, 1 second, 1 second. Sorry guys, so you can see when we are going to communicate with the client to server, right? The very first packet you are going to be initiate from this client to server connection, then firewall is going to intercept your connections. Means client is going to be initiate the connection to the server. In that situation, firewall is going to intercept your connections. And on behalf of this particular client, firewall is going to initiate the SSL session with the server. Right, that is your third packet. Means firewall initiate the SSL session with the server. Now, when server is going to reply again with the signed certificate, I'm going to discuss what is signed certificate and all. Then after receiving this particular request, server send a signed certificate to present to client. What happened? Firewall sign a copy of the server certificate. Means on behalf of this certificate, firewall is going to sign a now you're getting the new term certificate. Because SSL is going to do all communication based on certificates. Means any website you're going to access on the internet. If you're going to access any website on the internet, you're going to find that every website have the certificate. Every website you can see this is the certificate details. Means this has been signed by the issued by the certificate WR2, Google Trust Services. So everyone is going to be access the communication with the help of the certificate, and if there is no certificate, you cannot do the encryption and decryption in the your firewalls, right? So in that situation, you can see here firewall is going to be sign a certificate and send to the client for the authentication, and then after client verify the certificate from the firewall and they will initiate the end-to-end connectivity. But you can see when the connectivity is going to be initiated, your client to the firewall, this packet you can see, this is a tunnel. So this is the HTTPS connection is going to be there. And from server to firewall, you can see from server to firewall, firewall to server, again we have the tunnel. So till here and here we have the HTTPS, means this tunnel is created, means there is a secure connectivity has been created. And inside of the Palo Alto firewall or any other firewall, you can see there is a plain text packet is there, right? Give me 1 second. There's a plain text packet is there. Give me 1 second. So there is a plain text. There is no encryption decryption at all, right? There is no encryption decryption at all. And in the right side, you can see we have the tunnels from this to this location, and there is no encrypted, means there is complete encryption is there. So you can see this is written that SSL tunnel are established between the client and the firewall and the firewall to the server. Means client and the firewall. This is the first thing. And firewall to the server. This is the SSL tunnel. This is known as the SSL tunnel. Means it's a pure HTTPS connections from the client to the firewall and the firewall to the firewall decrypt the SSL traffic from the server into the plain text traffic and applies security policy to the traffic. Means anything is happening from the server to the firewall, client to the firewall, before it's going to server, it will convert that traffic into the plain text. It is going to make sure the traffic have the right kind of the data. Means no any kind of data leak is going to be happen, no any kind of the malware is going to process, no any kind of the your bad activity like a spying activity, any kind of the bad URL, you're not going to access any form of the encrypted packet. So that is going to be happen in this particular sections. All right. Now, what is the role of the certificate? So see, as I mentioned that certificate-based authentication is one of the highest level of the authentications or encryptions methods we have in the industry. Means if you're doing the anything on the SSL based communication, they use the certificate. And every client, let's suppose this is the PC and you're trying to access the server. That is a Facebook server. So your client, how basically in between you and your Facebook, we have the internet, right? You and your PC have the internet. Internet is accessible to any, means everyone, means anyone can access this internet. But how you are going to basically make sure when you're just uploading any file on the Facebook or downloading any data on the Facebook or gmail.com, it's not visible to the man in the middle. Man in the middle, that is any third party person, any hacker. Why it is not visible? Actually, your data is going from your PC to the Facebook server, but nobody is able to understand. But you able to understand what data you're sending. Your Gmail server, your Facebook server is able to understand what data you're sending and retrieving. Means it's readable to you. Means your PC is able to see your Gmail, your Google Drive and all. But how? So what happened? Your PC also have the certificate, right? And server also have the certificate. Means you just think about, you also have the key of the lock and this also have the key of the lock. So the person who have the key of the locks, they can easily open the lock and see what data you have. But in middle of the all intermediate devices, person unknown, they not have the key, no key. So they no key means they cannot do anything. So you can see even the PC, if I go in this particular PC, in this PC, if you just check that cert.mgr.msc, you can check in your PC as well. You're going to find your all computers are having this particular certificate. These certificates we have, like we have this, all certificates we have. And if I have that all certificates, that means I can able to decrypt all the traffic. This public known certificate, enterprise certificate, root CA certificate, means every certificate available in the my PC, and they based on that they can just go and do whatever they want to do that for the all communications. So similarly, if I want to do the decryptions from this PC to the internet, I need a certificate, and that certificate should be available on the firewall. So firewall can decrypt the traffic which is coming from the internet. You can see this, go in the certificate. In this certificate, you are going to check that. If you go in the certificate management, say this firewall have the all default trusted certificate authority, means any communication is happening from the firewall to the internet based destination, they can trust, they can do the encoding, decoding, or my encryption, decryption based on the predefined certificate. But how firewall can do the encryption decryption based on the PC? Because PC have the only those certificate which are the publicly known certificate, not for the any individual enterprise certificate. So there's two methods. I can generate certificate from my firewall locally. That is the my self certificate I can generate, and I can install in the all client. That is the one method that we are going to use in the our lab. Second method, I can purchase the certificate from any well-known vendor like Let's Encrypt, we have DigiCert. A lot of vendors are available in the market who provide a certificate. Same certificate I install in my firewall, and the same certificate is going to install in my client as well. So based on that, what is going to happen? They are going to build a trust. My firewall and client are going to build on the trust based on the either self-signed certificate or my third-party certificate. So any communication they are going to communicate from this firewall to the client, they are going to trust each other and they are able to encrypt and decrypt their packet. Any communication from firewall to the my any internet bit destination, if you're going to access that, that is also going to be same process because they have already trusted certificate. You can see the trusted certificate, so they can trust their communication from the client to the server to the firewall. So this is the second set of the communication, and then in that case we can achieve the encryption decryptions. Any question till here? Anyone have?
Yes, so you means I understand that certificates help in encryption and decryption for the traffic that is flowing between the client and the server. But how exactly is certificate doing that work to encrypt and decrypt? Can you explain that?
So the encryption decryption, there is a process that is known as the, if you let me show you. Let me try to find, yeah. So you guys know what is the SSL handshake happen? Pranez? All right.
Yeah, I know TCP commands.
Yeah, so before you understand how this server-based decryption encryption is happening, so and how certificate is going to be play a vital role. So see, we have to understand the SSL is handshake process, right? How the SSL handshake is going to happen. So before you initiating any client to server connectivity, what is going to happen? You have to must complete the three-way handshake process, right? You have to send the SYN packet, then you are going to get SYNAC packet acknowledgement, and then you have to do the complete establishment. Means you okay to start the communication. That is a three-way handshake process is going to be there. SYN, SYNAC, and acknowledgement and establishment. That is your step-by-step process. Then your actually SSL handshake start where certificates are going to be exchanged to do the verification, and they're going to be make sure we are going to ready to encrypt and decrypt the data. So first you have to be complete the SSL handshake process, and then second, your client hello packet is going to be sent. In this client hello packet, they are going to carry the multiple informations like a SSL protocol version, session ID, list of cipher suit. Means they are going to send a 16 cipher suit, and also the server and SNI detail also they're going to give that server name indication certificate as well. And also in certificate also they have the cipher details, and they also send the client hello extension. So based on this is the very first packet they're going to send that. Based on that, server is going to receive that certificate, and server is going to be select one of the out of 16 cipher, one cipher they are going to be selected. Selected one cipher, this is not mentioned here, but it's going to select one ciphers, and they're going to send the session ID, protocol version, and server hello extension, and that also server certificate. You can see, and it's required they will request the client certificate. It's optional, but client certificate is going to be there. So based on the server client hello and the server hello, then they go for the master pre-secret key creations, and based on that pre-master secret key creation, they will create one of the session key, and this session key will help to generate master secret use. Means master secret use generate the symmetric session key. Means basically we have to generate one of the master secret key. This is the pre master secret key is going to be generated. Then after that, your master secret key is going to be generated, and then after you are able to basically verify whatever certificate you're getting from the means certificate verification is going to happen in the very first place. Then your data encryption decryption is going to happen based on your master secret key and based on the symmetric session key they are going to be used. And then whatever traffic you're going to send, server is going to understand, client is going to understand, and then you can exchange your complete the message. So if you go here and try to decode here, SSL handshake process. So you can see this is the client hello. This is going to generate the multiple hello message, TLS version, support random generate data, client random. Server hello is a server respond the client protocol version, cipher shoot, client list is also that server random and certificate ID and everything. They exchange the certificate, server certificate key exchange is going to happen. Then client is going to authenticate it and then they will generate the pre-master secret key. The client use the server public key to encrypt the pre-master secret and send it back to the server. And after that, they will generate the session key that is known as a master key. And this master key is going to be always used. This generating the session key, both client and server use the client random and server random and pre-master secret independently to calculate the symmetric session key. And that is acting as a master key. And then after they can do all encryption and decryption. Same thing it's mentioned here in this particular things also. Master key is used to generate the symmetric session key that is acting as a pure master key or session key to just encrypt decrypt. So this is how things has happened, Pranesh. Okay.
So the server that is mentioned here, it is the firewall in our case.
This is the plain client. So there is no firewall. But what is going to happen in our case? In our case, this session is going to look like this. In our case, one is here, another is here. So one client, this server, this client, this server. Okay. So two session is going to be there. One here to here and one here to here.
Okay.
Okay, now how we are going to achieve that? So very first thing, I will go in particular my firewall and give me 1 second. I'll go here and then I will go in the device. I'll generate the certificate. We are going to create our own certificate. So I will go here, generate the certificate and I'll put the GUINET cert. And common name, I'll give that the interface IP 172.16.10.1. And I'll make as a root CA. Why root CA? Because this is going to be trusted server authority for this all clients. Whatever the client is coming to my firewall for any encryption decryptions, they are going to use that the trusted certificate. I'll use the random this cryptography settings, whatever it's suggesting that I'm not going to change that. And the expiration of the certificate 365 days. Country I will use for the India. So this is going to my India. Email I will use as a info@guinet.com. I can use the state as a Delhi. So you can put detail anything. Now you generate the certificate. That's simple. Certificate is generated. Post generated certificate. What is the next step, guys? Post generated certificate. You have to make this trusted root CA. You just have to select this certificate is going to be trusted root CA. This is the very first thing. Now, there is a two things more. Forward trusted root certificate. Forward trusted root certificate, that means if you're going to get any internet-based connectivity from LAN to internet, what is going to happen? Your certificate must be validated. Which certificate? Means trusted certificate. Forward trusted certificate, if you go and click on this particular help icon, you are going to find some definitions. Let me show you. Yeah, see, forward trust, right? And where it is. Forward trust, okay. Firewall use the certificate to sign of the server certificate of the firewall present to the client during the SSL forwarding decryption when certificate authority is signed and server certificate is listed in the firewall. So let me explain this one, but let me read first this one as well. The firewall use this certificate to sign a server certificate of the firewall present to the client during the and server side certificate is not in the trusted CA in the firewall. So what does mean? That means if trusted, if I'm just selecting the trusted forward trust certificate, that means we are talking about the legitimate side. Like this is the one of the website. If I go there, if you check this website, you have the valid certificates. If you go here and check that secure connections, you can see certificate is valid. So this kind of the communication, if I'm going to do that, then I will use the forward trusted certificate, means to just present all the SL handshake process and the encryption decryption for the authentication and the data sending and receiving. But if I have this kind of website, not secure, even I want to use this kind of the communication and I want to make sure my SL handshake is happening for this particular non-secure website as well. So I will use this forward untrusted certificate. So you can see here it's written that the firewall use this certificate to sign and present to the server certificate that firewall present to the client during the SSL forward proxy. Forward proxy means you are sending from LAN to internet traffic. Then you're going to present when certificate authority that sign the server certificate is in trusted list. Trusted list means you are the valid certificate. Trusted list means you are the valid certificate. Now the second statement, if you're reading it here, the firewall uses this certificate to sign copy to the server certificate. That same, everything is same till here. Okay, everything is same. When the CA that sign the server certificate is not trusted in the CA list. So this is not trusted in the CA list, this kind of certificate. Okay, so I will just click OK, that's fine. And I will commit this. You can see the certificate is valid. After this, I will go in my this client, and every client need to install this certificate. If you want to part of the SL decryption encryption process, you must have to include this certificate in your database. So how it is going to happen? So you go here, and we cannot copy in certificate directly in the virtual PC. So we'll log into the firewall. We can download certificate in the client PC. In case of your production, you can use your USB drive. You can use such kind of the, what I can say, GPU, Global Policy Update. You can use the MDM, Mobile Device Manager. And from there, you can just update the certificate. But now we are in the virtually, so I will just simply log into the firewall. And I can download the certificate in my local PC. So I will go here. And log in this PC. Okay, so let me complete this. I'll go here. I'll go in the certificate. And I will simply export the certificate in the PC. So just export certificate without any private key, and just let me go here. Might be there's a duplicate certificate. Earlier I used the same name, but no worry, I'll install the new certificate again in my PC. So this is a certificate. I'll just install it. Install the certificate. Click here. Place this certificate in my trusted certificate authority. Okay. Next. Finish. So now this certificate has been going to install. Okay. So if you just check it, cert manager, certmgr.msc, you are going to find certificate. There's two certificate you can see. You are able to find two certificates. So one is old. This is the new. This one is old. So let me delete this one. I don't need this one. So I can delete this one. Yeah. I just need this one. This we created today, 28/6. And you see this is my certificate detail. We put the email and all. So everything is available. No problem. So we are good now. Now, what is the next step? We will create the SL decryption policy. So I need to go in the policy sections. And after going in the policy, you have the decryption policy. In this decryption policy, you have to go and create the decryption policy. I'll go here. I'll create a decryption policy. I'll put as a SSL decryption policy. Source is going to this is going to my trust source. And I can just going to be get anything 192.16.10.0/24. Destination is going to my untrust. Services optional. No decrypt, you should have to use a decrypt. And in this decrypt, you have the SSL forward proxy. So you have to use the SSL forward proxy. We have the even inbound decryptions as well. SSH proxy, but we have to use the SSL forward proxy. Decryption profile is like you should use the default or you can just use the none. It's up to you. Decryption profile is basically some additional checks like any certificate expiry you want to block, any restricted sessions you want to any certificate extension you want to restrict, any if you want to block any kind of the unknown certificate, so you can do that. So better you just use the default. No need to do any changes here, and that's all. Click OK. Now you created SL decryption profile. After this, let's suppose this PC earlier not able to block any virus file which was the HTTPS based virus file. But now I can go here and apply see, we have already antivirus profile created here. So now if I go and apply this antivirus profile in my trust to untrust policy, even I'm going to download any file which is the HTTPS, my firewall is going to understand this is the virus file, and based on that, they are going to block that connections. So how I can do that? I can go trust to untrust policy and just simply go in the actions, and I can just use that antivirus. And you will see that if I commit now and try to download some HTTPS based virus file, and even let me use this file blocking as well. Earlier I used for the HTTP, but now I'll try to download some PDF file, which is the HTTPS based PDF file. That all is going to block because we are going to do the SSL decryptions. And also you will see that my browser are verifying and authenticating that all SSL session based on my local certificate. Wait for a while, we'll see that after that. Okay, so now you're good. Now if I go here and try to access the any kind of the internet website, should able to access. Yeah. And let me try to download some test virus file now. And this is the one of the EICRNT malware. This is a purely HTTPS website. So I'll go here and try to download. And also I'll try to find some PDF file download. Oh, it's not taking that our certificate. Why? It should take the our certificate. It's just taking the global certificate. Okay, now you'll check that. Let me check the Google one. Okay, not taking. Okay, let me try. It should take our certificate because we already configured SSL decryptions. But let me try to download some file and we'll check that after that what is happening. So this is the my HTTPS based website. You can see this is the HTTPS based SSL enabled protocol virus file. So let me try to download this virus file. And see, this has been completely blocked. HTTPS. And now you'll see that secure connection. If you go here, certificate, you are going to find this is our certificate. This is what I want to show you. So these are the global certificates. So when you go for the virus, because virus is going to identify, it's basically a malware and decryption help to understand those malware and they just block. So you can see this certificate is ours and this is basically blocking the certificate and this is the HTTPS connection. You can see this is the completely HTTPS connections. Similarly, if I go and try to block the sample PDF file download and try to download any file, let me try for this one. See, this is also blocked. We cannot able to open. And if you check that here, and if you go here in the monitor sections and check in the threads, I'll check in the threads. In the threads, you're going to find that this file is basically 443 and this has been blocked. Earlier we tested for the 80, but now we are doing testing for the 443 and this has been blocked. Similarly, if you go for the data filtering, in this data filtering also you're going to see that simple PDF and see this is the 443. Earlier we blocked for the 80. So now because of the SSL decryptions, we able to do that. And if you want to check that decryption logs as well, so let me show that. If you go to the decryptions, you'll find the decryption logs as well, that which all file has been decrypted. Probably you're not able to understand the logs, but you're going to get why decryption. Might be it will take some time to come here, but your decryption log is also going to be there after some time. You just have to wait for file. So we'll see later, no worry. And if you go and check the traffic as well, and you just enable the column, yeah, decrypted, you can see this is enable a decrypted column. So let me check that. Where are decryptions? Yeah, so see, this is the yes. So the traffic which has been decrypted as yes flag, you're going to find all the traffic which all decrypted. This see, this all has been decrypted. The flag you are seeing that this all traffic has been decrypted. So the traffic which are decrypted, you're going to get a flag, and the traffic which are not decrypted, you are not going to get a flag. So you also find the decryption flag in here. So this all proving that your traffic is getting decrypted. Okay, clear, everyone? All right, so this log is not coming. Probably it will come later. Now, this is known as the outbound decryption. This is known as a forward proxy. Means if you go from the LAN to WAN, then you can do such way decryptions. Similarly, if you want to do for the, let's suppose your traffic is coming from the internet and you want to decrypt the traffic for the any server, let's suppose the FTP server, then how you can do the decryptions? The process of the policy creation is going to be like this. You just go here. Let me show you. You go here and you just put as a inbound decryption. SSL decryption. Right? And here your source zone is going to be untrust, any address going to trust. Let's take an example, or DMG. And you want to decrypt. You have to change as a inbound decryptions. Now, the key important thing is you require the server certificate. If you're doing the inbound decryptions, you always require your server certificate, not the firewall certificate. If you're going to outbound decryptions, firewall certificate must be installed. Means you generate the self-signed firewall certificate or purchase any certificate that install in the firewall and install in the client. But in inbound decryptions, you have to get your actual server certificate from the server owner. So we don't have that certificate as of now. But in case your server owner have the certificate, you have to import those certificate. Let's suppose GoINET cert I'm going to use, or let me use this my DG cert. So you just click it here and done. You can apply the default. But this certificate must be get from the your server owner. And you just have to import this certificate in your object sections. You go here, certificate manager, no device. And after going in device, you can import the certificate from the server owner. If you have the server owner giving the certificate, or you want to import from the remote location, SCEP protocol by using that, you can do that also. So we don't have, then you have just to copy, and then after you just call in the policy, and then it is going to be commit, then your this job is also done. So this is your inbound decryption. This one is your outbound decryptions. You're going for outbound decryptions. Now, the last is basically you have the one more decryptions. SSH, let's suppose you in the SSH decryptions. Decryption. In this again, let's suppose you want to go for the LAN to WAN. Trust, you want to go to the untrust. Untrust. And you want to decrypt. If you're making the no decrypt, means decryption is not going to happen. So you are going to do decryptions. You just use this SSH proxy. What is SSH proxy? If you're doing any SSH connection, generally we not use this. Any SSH connections. Let this PC is trying to do SSH to this particular server. So in this case, also decryption is going to be happen with the same certificate. So SSH based proxy, if you're going to use that, then it is going to do decryptions and encryptions. So generally we not required, but yes, we can use the SSH decryptions as well if you want to do that. Okay. So that's all for the SSL decryption, certificate management, outbound SSL decryption, inbound SSL decryptions. Any question, please let me know. And how
सर
SSL is going to
सर
happen. Yes.
सर पालो अल्टो में फिर से सर लॉगिन नहीं हो रहा है
What issue you're getting?
सर लॉगिन आईडी पासवर्ड क्रेडेंशियल गलत बोल रहा है सर बार बार
Just change the static IP address of the firewall. Just go log into the firewall as CLI. Okay.
सीएलआई में ऐसा नहीं हो रहा है सर सीएलआई में ऐसा नहीं हो रहा है ये देखिए ना सर, मैं स्क्रीन शेयर कर रहा हूँ।
Don't share your username and password, okay?
ओके ओके
Make sure.
ओके।
Okay. Please share your screen.
हम्म,
Login your firewall.
अ, हम्म,
हो तो गया यार.
सर अभी हो गया सर, कि नहीं समझ में आ रहा सर, 10 बार नहीं हो रहा है, अचानक हो गया अभी।
Just do one thing. Just restart the firewall, okay? And wipe the firewall again and try
हाँ
to do the static IP configuration of your firewall. Okay? It must be going to happen. You must doing some typo, Mr. Das. Okay?
ओके सर, ठीक है सर।
Okay.
ओके
Please
सर,
do it.
थैंक यू सर।
Thank you. Thank you, everyone. See you again. Bye bye. Take care.